Hello everyone, it's April the 1st. We have recovered from what can only be called a terrible situation yesterday. But today is a new day. Now we're not going to give up. We're going to keep going and see what we have going forward. But there will be a change. I think I'll set up a hard deadline. 45 minutes. Let's do that. 45 minutes. If there's no clear light at the end of the tunnel, we're going to just call it. All right, 45 minutes. All right, let's take a look. First day. Palindrome. Palindrome given a head. Palindrome linked list. Okay, so we can detect whether linked list is palindrome or not. Given head, return true if it is a palindrome. Okay. So the only difference is it's a linked list, and can you do it in ON time and O1 space? Well, ON time is for sure, and ON space is pretty simple. We can actually do that right now. We can just write the ON space solution right now. And we actually need to create a new directory. It's gonna be nope. Wait, what's it? Oh, it's been 2021. April challenge. All right, and I'm gonna copy this into our April. And then also there's gonna be April. Pull it up. I'm gonna get the font a little bit bigger. It's too small. All right. So the ON space solution is very straightforward. We can copy it down. All right, I'm gonna copy it down, and then that's it. When I copy it down, I'm gonna create a list. I'm gonna say the list is gonna be this. And then node is going to be head, while node, I'm going to say list.append, node.val, and node equals node.next. Oh, we also need to copy in the node here as well. I forgot to do that. So this one, after we're done, we're going to return. List equals list. Right, so we don't test this because it's linked list, and we need to test on just a few of the edge cases. I'm going to test a regular case, and this is a regular case, and this is a regular failed case. Oh, too fast. A regular failed case, a single node shall pass, single node shall pass, and also empty, because we, oh, empty is, okay, that's it. I think this one shall pass. Yeah, this one pass, which, oh, huh, there's a much faster here. What happened here? Interesting. Anyway, what's the length? 10 to the 5th. Alright, so this one is a forward solution with ON space. And ON in the time. And we run at 808 milliseconds. Give us 30% ranking. Alright, so this is the ON. So we pass it first. This probably has solution. Oh, it does not. Alright, let's try to think about O1 space. What is O1 space? O1 space means we have to do it like along the linked list, right? That's O1 space, or we have just something on the outside. So if we can go from both sides in, that probably is not likely, right? We cannot go both sides in. If we want to go both sides in, that means we have to have the reverse. I mean, maybe we can. I mean, if we go through it once, we know the total number of nodes, right? And then we can just walk down towards the starting position of supposedly the second part, and from here we reverse everything. So from here we know there's 4, so we do 1, 2 steps, or we should say the third node, and starting from here we're going to reverse. So this one will be the node, and then we reverse everything down the line. And after reverse, we go from here, we move in, towards each other, and we're going to note on here as well. So this is going to be pointing to like none, and this will be pointing to none. So we're going to go in, and they're going to match, or they're not matching. Once we're done, then we go from here, and then we go from there, and we reverse everything again. So that's O1 involving reversing. Do you think it is a good strategy? Well, what else can you think of? I mean, there's no other way. You have to reverse it. I think it'll be easier to reverse the first half. Right? You just walk, so you can walk to the last node. And then you reverse from start until this last node. You just put the last node pointed to none. Right? And then you put another one here. So this link doesn't exist. But this one we pointing to none. So basically we split this into 2 linked lists. And then we reverse one linked list, then we compare the 2. Afterwards, we reverse this again, and then we link them back. I'm going to try this one. Yeah, let's try this one. This at least is O1 in space. See if it works. O1 in space. So when you write a function called reverse, I want to write a few more functions. So first function is called get length, right? When you have a head, it'll be a link node, and then we just say node equals head, and when I say count is 0, and then while node count plus equals 1, and node equals node.next. Right, on the return count. Right, so this is when we count how many nodes there are, and then next one we're gonna say reverse. Right, reverse. We have a head. We probably need also a tail. We probably do we need a tail? So reverse, pointing back, and then we probably no. Let's just make it. Let's make it generic, right? Let's make it generic. Make it generic. So we just need a head. right? Which is in the head, this node. So I've done this before many times, but I think I still need to draw it out, how to do the reverse. That's not hard. It's just so we need to. I think if I remember correctly, there are three nodes we need. We need the current node, we need the previous node, and we need the next node, right? And then we can say current node gonna pointing back to the previous node, and then next node moving forward, previous node moving to current node, and the current node moving to the new node position, and then we rinse and repeat, rinse and repeat. And then when we reach the end, current node pointing back, next node cannot move forward if it's none, so we don't move the next node. And then P gonna move to the end, the current node is gonna become none. All right, I think that's fine. So we just have pre, current, and next, right? It's gonna be pre gonna be none, current gonna be head, next gonna be head dot next. Now head definitely has next because we have the requirement, right? The range is 1. And then what we say is while current, we say current dot next equals pre, right? Then next, then current, then pre equals current, current equals next, and next equals next dot next. If next is not none, then next move forward. Next equals next, current already moved to next pre, and then we can repeat this. So that will reverse everything, right? That will reverse everything until the end. Perfect. So that's reverse, and when return pre. That's the end. That's the head of the new head. So what we're gonna do, count equals self.get length. I forgot a self. Self here. Right. So self.get this, and then we need to separate the first one, which is even. It's even, it'll be divided by 2. If it's odd, it's also divided by 2. So we're going to say node equals head, and for this, in range, count divided by 2, right? That's how many times we need to do. Node equals node dot next. Let's see if it makes sense. So we have 4, so count divided by 4 by 2 will be 2. We did 2 times. Node is here. Node is 1 time. And 2 times. Well, I should move too far. So I think it have to be -1. So if it's 4, divided by 2 is 2. It would be 1. So just do 1 step. Yep. And if it's 2, divided by 2 is 1. That's 0. That's a 0 step. Right? So when we do this, and node will be currently at the end. Node will be currently at the end. Then we don't even have to return the pre. There's no because we already have it. I guess so. We don't have to return this. Yeah, I think we don't have to return this. So all we need to do now, we just say end. So notice this. So I node. We actually not call it node. We call it first half. First half end, right? And more explicit, first half end. And then we're going to call it next second half start, right? Second half start. It depends. It depends. I'm going to say if count is divided by 2, not divided by 2, so it's odd, then we're going to say next second half start equals first half end done next, and first half end done next. Right? Else, if it's even, then middle second half start equals middle with none. We have no middle, and then second half first end done next. Right? Okay. So now we have all this. Now we're just gonna reverse. Reverse head, right? Oh, we haven't set it yet. So when you set, we're gonna set, say, first half dot next equals none, and this would be cut out the first half linked list, and now we reverse it. After reverse it, we already have a head. Then we just say node 1, node 2 equals first half and second half start. Now while node 1 and node 2, we say if node 1 is equal to node 2, not equal to node 2.val, that's going to return false directly. I don't even want to change it back. You probably should change it back. Input res equals true, and then I'm going to say res equals false, and I'm going to break it. Otherwise, node 1 equals node 1.next, and node 2 equals node 2.next, right? So they keep moving until we hit the end. Now while we hit the end, it doesn't matter. We're just going to reverse, not head, but first half end. So we reversed it back, and then first half end done. Actually, we're going to put this one the same, right? The middle should be the same. So the middle is always the same. Yeah, so the middle will always be this, right? The middle will always be this. So if it's not equal, if it's like even odd number, then we call it middle.next. Else, we can actually put this in one line and say this equal. Else, just equal to middle, right? And then we put this comment as a separation, natural separation between these two. And then this will be restore order. So we reverse, and then this one will equal to middle. We can change the rest, and then we're going to return rest. Okay. I'm not sure if it's going to be faster, but I think this is definitely O1 in space. I'm going to run it. Oh, this is the other issue. So we run 1. Have we waited enough? Yeah, I think we waited enough. Oh, none type doesn't have. Okay. Alright, if it's a single, then we have an issue. If it's single, then this will be 1. That will be itself. And then so if it's a single, then we just return self. Alright, count. We say if count is 1, well, I'm just going to return true, because single is always true. Yeah, we don't have to test this anymore. So we'll test this. 1, 2, 3, 4, 5. Run it. Hi. Now come to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this one shall be false. Oh, misspell. Didn't show me that it's misspelled. Where? Line 30. Wait, line second half. Again. Oh my god. Why you call it directly? It's self.reverse. Did you call self first? No, you didn't even call self first. Self.reverse. I didn't call self.getLength. Okay, try it again. False, good. So next one we're gonna try to true. Let's do odd number. Alright, I think this should be right. So 01 space. Yep. Let's see. How was the performance? Even worse performance. Anyway, so this is 01 space. So I'm gonna put it here, and we say this is 01 space. We split the linked list into two halves. Reverse the first half, then compare the two. Then compare the two halves, and then compare the two halves. Right. So this one give us also 01 in time complexity, ON in time complexity, and it's 916 milliseconds. You think these solutions? Oh, I have spikes. The memory. There's even better solution here. What are they? Curious. Fast and slow. Oh, are we talking about we link this together and go into a loop? I don't know. It's a fast and slow. So one goes faster. Well, if it's a loop with a catch up, then what? Apparently that is the standard solution. So I think it's not necessary to reverse anything. I mean, I don't even have to do it. Do it. Oh no, yeah, we have to because we don't want to store it somewhere else. So you're cutting in half, right? That's cutting in half. What? How do you solve with fast and slow? All right, let's take a look. I don't know. So fast and slow. That's very interesting. Man, yesterday was so bad, and today they give us something easy. Yeah, it is easy. Have I done this before? Nope. What's the fast and slow? O(n) time and space. 5 lines. How many lines do you have? 1, 2, 3, 4, 5, 6. 6 lines. Well, if we put these two together, then that's 5 lines. Alright, this one says reversing the second half. Wait, they use fast and slow to reverse? No, this is reverse. they do make it into this. Oh, they use fast and slow to determine where you're gonna end up in the middle. Ah, now I see. Ah, that's what fast and slow is for. So it is to break it open. But with fast and slow, you break it open without having to count. So we go one run, and we already know where the center is. Yes. What if it's odd numbers? Odd numbers, so like going two at a time. Two, right? Odd number will be here. And then yeah, how do you deal with odd number? Odd number, say if this is an actual number, then fast 1, 2, we add a number, and this one is 1 and 2. Slow gonna be here, right? Slow gonna be here, and slow gonna be here, which means the fast. If we keep going, and now will be none, right? So the fast is not going to move. Fast going to stay. Fast going to stay here. So I guess just I guess it doesn't matter, right? Doesn't really matter. The fast and the slow. Like slow is always going to be end here. The fast can end here or end with the actual thing. So it doesn't matter. So if we want to check, we always go. One is going from front, and when I reverse this from here, yeah, and reverse from here, so we can turn this. And depending on, how do you determine? Because it could either be here, right, or it's the actual number. But actual number, if we want to keep going, we have to check the next, and check the next. It's actually bad because f dot next is null, so we don't do that anymore. So the fast will just stop here, and the slow will also stop here, right? So no matter what, slow gonna stop either in the center or the beginning, the center, which means this one we don't care, or it has to be part. So that depends on where the fast is. If fast is null, then we start from here to build and the reverse. If fast is not null, then we move slow forward and build a reverse. And we then moving them together inside. Okay, so we can use the exact same thing, but we don't have to do, what we don't have to do is we don't have to count, right? So count is avoided because we use fast and slow. So this is using fast and slow pointers to traverse the linked list in one shot to identify the center position. Right? So I'm going to say fast, slow equals head and head. Say while fast and fast on next. Fast equals fast on next on next. Slow equals slow down next. Yeah, let's not open this one up. Slow down next. Alright, so after we reach it, we're gonna check. I'm gonna say if fast, that means if fast, so we're gonna have a mid, right? Mid equals if fast, that means mid equals slow. If fast, actually we'll have also move slow forward. So let's just do if fast, then mid equals slow, and slow equals slow down next, right? So that's the beginning. If else, then mid equals none. So we don't have a mid. Then, oh, mid is always going to be slow. Yeah, mid will be the point where, hold on, I'm thinking about restoration. We need to restore this. So we have a mid. So mid dot next is gonna point into next, right? Or the mid is going to be, okay, so here, so mid equals slow, otherwise mid gonna equal to mid is equal to slow no matter what. Yeah, mid is going to equal to slow no matter what. Mid gonna be slow. Yes, mid is going to be slow. No, mid is not going to be slow because we actually already lost the mid. Because when we reverse, right, when we reverse, it's slow is the end, right? Slow is the end. Or you could call it next. We break it into two, so it's just the second half. We're going to call it second half start is going to be slow, no matter what, right? No matter what. And if fast, then we slow, move to the next one. And then we're going to call slow down next, going to be none, right? So now we seal off. We seal it off, and then we're going to call self.reverse. Self.reverse. Oh, we need an end node. How do we know the end node? How can we reverse it? We reverse. Oh, we don't have to do this. We reverse from the slow, right? We self.reverse from the slow. And then automatically we'll point into, yeah, automatically it'll point to none. So we reverse the slow. So the slow is reversed, which means the second half is reversed. Yeah, the second half is reversed. We'll call it not second half. This is like a mid. So second half is reversed, and then I'm going to run the same one. I'm going to say first and second. First and second can equal to, second half. We do need to return the last one. We do need to return pre here because we're going to say first and second. So first is going to be head, second is going to be on reverse. That basically is the tail, right? And then we'll just say while f.val equals to while f and s, f.val if f.val is not equal to s.val, So that's going to be true. It's going to give us rest equals false, and a break. Right, now we have the answer. We just need to reverse it back. How do we reverse it back? We have the front, but it's moving, so we need to have the front on this. So actually, we're going to do a tail is equal to this, and do tail, and then it's going to be tail, right? So we don't move tail. Then we can do self dot reverse tail. This is actually going to give us the last node. Right, this is going to give us the last node. This is going to give us the last node, which we're going to call mid.next. We're just going to call mid.next equals this. This is the restoration. This is the restoration. And then return rest. Right, so here is the first step. Let me say find the middle node, right? And this is record the node needed for restoration. This one is locate the start of the second half. I'm going to reverse it, which gave us the tail, which is the tail of the actual linked list. And we do these two. We go them together. F equals f dot next. I forgot this. S equals s dot next. So we moving. It wouldn't probably be better. We call it left and right, huh? Yeah, I think it would be better if I call it left and right. So left and right, and then left and right. It's gonna be left, be right. And after they're done, they exit. We know the answer here, and this mid is the node that is needed to restoration, right? It's the end node, right? The end node of slow. If it's the end node of slow, that's actually not working. Like if it's even number, 1, 2, 3, 4, right? So fast node gonna be none, slow node be here, it's gonna be 1, 2, 1, 2, right? So when we get out, the slow node so the reverse, we can always return the tail, and it's just the front, the end node when we go to the front. Yeah, that is the trouble. That is the trouble, because if we reverse, we don't have. So if we do this way, we cannot restore. We cannot restore. Because the situation is just if it's even number. We add a dummy node at the front. Because if it's odd number, it's easy to solve. The odd number, the tail. If it's the odd number, the fast is gonna end at the last node, and the slow gonna end at the mid node, which is perfect. But if it's the even number is going to be problematic. Even number, the fast node is gonna end at null, and the slow node is gonna end also, but slow node is not ending at the middle. The slow node is actually ending at the end of the so we actually don't know. So I need like 2 slow nodes. All right, we need 2 slow nodes in order to do this. Yeah, we need 2 slow nodes. It's like slow 1 and slow 2. Actually, it's not going to be a slow node. It's just going to be the end of the first half. So first half end. The first half end has to be. Oh, I'm going to add a dummy node. So I'm going to say dummy equals list node. Next equals head, right? And then fast, slow, first half end is going to be dummy. And then first half end equals first half end on next. All right, so this one will record the first half end. So we have a first half end. And then we don't need the mid node. This one is not necessary. Right, this one is not necessary. But we do have to push if fast node, that means slow equals slow down next. That's the start of the second half, right? That's the start of the second half. If not, then this is the start of the second half itself. Now we run this. Let's make it more, so we're gonna say second half start equals slow down next, if fast, else slow, right? So this is to identify the second half. And then we run the reverse on the second half. And after we run the reverse, the second half can be this, second half can be here. We run the second half, and then we reverse it, and we will return the end. So this one gave us a tail. That's good. And then when you go left, right, head and tail, we're going to do this, or shenanigans. After this is done, we're going to reverse tail again. When we reverse tail, we get the second half start again, right? We get a second half start. And when we get a second half start, we can call it first half end. Actually, we already have it. This is the second half start. How do we know the linker? So first half end. So either first half end dot next and dot next has to equal the second half start. So we have the second half start, right? We have the second half start here. And then we're going to call the linker. Linker, actually, this is going to be the linker node. The linker node either is the first half and, so we're going to just let's call linker in the middle, right? So these are the linker. And then we say L slow, and then we say linker gonna equal, actually I want to do this. If fast, right, then second half start equals slow down next, and linker equals to linker down next. Else second half start equals to slow. Right, don't need this. And then we run the tail, which actually can be done here. We don't even need the tail. Right, we don't need this. So left and right, blah blah blah. When it's done, oh, we do need it because we need to reverse it. Alright, we do need it. So we're going to run the tail, right? But we don't need to return anything. So I'm going to restore. After restore, we just call linker.next equals second half start. Then we return rest. Okay, so I think that is the other one. Try it. I think I spelled it wrong. Instead of linker, I put line. It's actually linker. Oh, and also restoration, and then also dummy next equals none. So we need to cut that as well. This give us okay. So this one pass. Can I run all of them? Yeah, I have multiple. That's even true. 2. Okay, run it again. Oh, we had an issue with single. We have an issue with single earlier as well. So with single, so we don't do. So slow is going to be pointing to the head, and a fast is going to be pointing to the head. So we say fast, then second half start is going to be special case. I think this is special case. So we're just going to say if head.next is none, then return true. Yeah, a special case. A special case, consider specially. There we go. Yeah, it's also slow, but that's that situation. I guess if you don't restall, would it be faster? They do not restall, right? They just they run a reverse, and then yeah, they did not restall. Let's try if we do not restall. If we do not restall, do they consider the special case? They don't even consider the special case. Maybe if you don't do it, you don't need to consider the special case. If you don't restall, then fast and slow will stay in the first node. And then if fast, well, yeah, that's true. If fast, then the slow has to move forward. And the slow has to move forward. And then we're going to do a reverse. How do you do reverse if there's only one node and the slow is already I think that's just a special case. We'll just check it. This one will be without restall, without restoration, right? So we don't need this, and we don't need linker. We just need a fast and slow. And we do this is not needed. Afterwards, then we can just call it slow. So slow will be the start of the second one. We don't need this. And I'm going to call tail equals this. And then I don't even need to call tail because we don't restall. And this will just be slow. Right? Do this, and blah, blah, blah. We don't reverse, we directly return. Right? Try it. And this case is taken care of. Try a failed one. Yeah, this is without restall. I think this one shall pass. Without restall. I think we'll be run at the same time. Yeah, it'll be running at the same time. So this is without restore. And also we're gonna save it here. So this is with restoration. This is with restoration. And then the final solution we're gonna post here is the one that without restoration. And that's solution 2, solution 3, solution 4 without restoration. Yep. All right. That will be it. That will be it. We start a journey in April. What happened here? All right. All right. That's it. It's well, I mean, we've been bombarded with hard for 2 days, so today is going to be a break, and we did it within expectation, right? Within expectation. I think the first solution came out in like about 10 minutes, and this one will be a little bit longer than 10 minutes, I think. Oh, actually, we forgot to fix this. It's a little bit longer, maybe another like 10 minutes to solve this one. And we look at the solutions, so we get 2 more, one with restoration, the other without. And yeah, that's it. I'll end it today and see you guys tomorrow. Adios.